Today we're going to talk about derivatives of polynomials. In order to take the derivative of a polynomial, we always use the definition of the derivative as our starting point for learning this concept. Remember, the interior part of the definition of the derivative is really the secant slope. It would be the slope if we had 2 points, a y2 minus y1, and the x2 minus the x1 results in the bottom part being just h. If we take the limit of the secant slope, we get the slope with the tangent line, or the slope at exactly 1 point, and we're going to represent that as dy dx. So as we do this, we have the dy dx portion. We have y equals x. So if we substitute x plus h into that equation, we get x plus h substituted into just x is still just x plus h. And of course, x substituted in to the equation for just x results in just x. If we simplify, the x and the minus x cancel, and we're left with h over h. And that cancels to leave us with 1. So we really don't have anything to substitute the h approaches 0 into. So that means that the derivative dy dx for any line y equals x is going to be just 1. So we would say that y prime equals x. We can repeat this process for y equals x squared. We start again with the definition of the derivative, which is the limit of the secant slope. Now this time we're going to substitute x plus h into x squared and x into x squared. That gives us the equations so that we have x plus h quantity squared minus x squared. Now if we distribute out, in this case we can FOIL since it's a quadratic, the left-hand portion becomes x squared plus 2xh plus h squared. That corresponds to this x plus h quantity squared. We still have the minus x squared part. Now the x squared and the minus x squared cancel, leaving us with 2xh plus h squared. Now we can factor out an h and cancel that, leaving us with just the 2x plus h. Now, unlike the first problem we did, we actually still have an h remaining, which means we're now going to substitute h approaches 0, and that leaves us with just 2x. What that means is that our derivative, y prime, or dy dx, for y equals x squared is always going to come out to be 2x. Oh, I miswrote up here. Y equals x, y prime equals 1. We can repeat this process again for h cubed. So we have x plus h quantity cubed minus x cubed. If we FOIL out, distribute out the x plus h quantity cubed, we end up with x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed was from this second portion all over h. Now similarly from before, we're going to cancel the common terms. So the x cubed minus x cubed. Now we can factor an h out of every term in order to cancel. One thing really important to remember is if you don't factor, then you don't cancel. A lot of students make a common error when they attempt to cancel something, for example, like this, and they cancel poorly. Okay, so if it doesn't factor out, it doesn't cancel. So you need to make sure you actually have a factor. So once we factor out an h, we're left with 3x squared h plus 3h squared plus h cubed over h. Once we factor out an h, we're going to take this h out. This one factors out, leaves me with 1. This leaves me with 2. Once it factors, I can cancel, leaving me with no h on the denominator, and I reduced by an h on the top. Now when the h approaches 0, we're left with 3x squared. So that means that if y equals x cubed, y prime, or the slope, equals 3x squared. So the last one we're going to do is y equals the square root of x, or x to the 1/2 power. It's a little more complicated because we have to do conjugates using the definition, but x plus h substitutes in to give us the square root of x plus h. X substitutes in to give us just the square root of x. So we're still doing the limit of our secant slope. Okay, this time we're going to have to use the conjugate pair. So since I have an a minus b, I multiply by a plus b over a plus b, because remember, I'm really just multiplying by a giant number 1. So I'm not changing the value of the fraction. I'm multiplying by 1. Now, keep in mind that the non-conjugate pair on the bottom, they don't get put together. They're not friends. They don't get together. The only ones that get together are the top. The a minus b times the a plus b becomes a squared minus b squared because the conjugate pair is a difference of squares. Notice that I put the parentheses around this to remind myself I have to distribute that negative. The most common mistake on conjugates is that people don't distribute the negative appropriately. Now, once I simplify that out, the x plus h minus the x cancels, leaving a positive h on top. Notice I didn't put this denominator together because they were a non-pair, so it's still a part here. Now the h can cancel, leaves a 1. So when you're canceling, you need to replace your cancellation with a 1 or a negative 1 if it's going to be left so that it doesn't look like there's no term at all. There is a term there, it's 1. Now that we no longer have h alone on the bottom, we can substitute in without getting a 0 denominator. So that leaves us with the first term being root x. The second term was already root x. Adding 1 root x plus a second root x makes 2 roots of x, which I can leave that way, or I can write out in this pattern. So notice what happens. If y equals x to the 1/2, y prime equals 1/2 x to the negative 1/2. Do you happen to notice a pattern for what happened? Let's see if we can make a list. When we had y equals x, y prime was 1. When y equals x squared, y prime was 2, and then x to the 1. When y equals x cubed, y prime became 3, x squared. We can even think about this y equals x as y prime equals 1, x to the 0. 2x to the 1, 3x squared. When y equaled x to the 1/2, y prime was 1/2 x to the negative 1/2. So notice our pattern. If we have a polynomial function or an x raised to a power by itself, our process for finding the derivative was to bring the n down, and then we reduce the power of each by 1. So our rule is if we have x raised to a power, the derivative is the power constant moves down to the front, and then we have x to the n minus 1. So let's do some practice. So we've written our power rule here again, just so you have it on this page as well. Constant multiple rule is really nice because what that means, for example, is if I had y equal to 3x to the 7, I can simply keep the 3 and take the derivative of x to the 7, which is 7x to the 6. That means my derivative is 21x to the 6. The other rule is that when we have addition and subtraction, I can simply do the separate pieces. So for example 1, when I'm finding this derivative, I don't have to try to do the entire polynomial at once. When I find the derivative, f of x prime, so the first derivative, I'm going to multiply the 6 times 5 to get 30, and I'm going to reduce the power by 1. I'm going to multiply negative 3 times 4 to get negative 12, and reduce the power by 1. I'm going to multiply 3 times 2 to get 6, and reduce the power by 1. I'm going to multiply to get negative 16 and reduce the power by 1. Notice that this 17 is a constant. That really means we have no x's there. So if we were to bring the 0 down, I would get 0 times 17, and it really doesn't matter what x power we have because we have a 0. The other way to think about that is that this piece is really like having y equal to 17, which is a horizontal line. And horizontal lines always have a slope of 0. One way to use a mnemonic device to help you remember those, I use Hoivux, which is a nonsense term. It doesn't really mean anything. It's a mnemonic device very much like PEMDAS to help you remember order of operations. Horizontal is a 0 slope. It's always a y equals equation, like y equals a constant. Vertical has an undefined slope, and it's an x equals equation. So a vertical line or a vertical asymptote would be an x equals equation. So Hoivux is just something you say over and over to help you remember that when you have a constant, the slope is 0. Because this is a y equals equation. F of x is a y equals. So if we were looking for the slope of the tangent line, that's the same thing as saying find the derivative. Those mean the same thing. So f prime of x in this case, I bring the 2 down to multiply and get 6, x to the first power. This negative 4x, remember, is like x to the first, so I get negative 4x to the 0. But anything to the 0 power is just 1, so I really don't have to list that. and the derivative of a constant is 0. So this would tell me what the slope of the tangent is at any x. If I want the derivative specifically at x equals 1, I would have to substitute 1 in and get the slope as 2. Okay, so we're going to go through selected pieces of your homework, or classwork rather. The classwork you're going to have to submit as a graded assignment. Remember, your textbook work you're actually saving in your notebook to be graded at your midterm, quarter exam, and final exams. So the derivative for number 1 is 20x to the 4th power minus 6x to the 1st power. Let's skip over to number 4. In order to do this, I have to FOIL this one out. 9x squared minus 12x plus 4. Now I can take the derivative of the polynomial, 18x minus 12, and then I'm not going to write the plus 0 for the derivative of the constant. So now these are pretty much the same, but they're asking for the derivative at a particular value. So for example, if we work to number 10, f prime at any x is 15x squared minus 6x plus 2x to the 0. So we're not going to list x to the 0. It would be gone. And the derivative of negative 6 is just 0. So then f prime of a half, so watch your notation. 1/2 squared is 1/4, so this would be 15/4. 6 times 1/2 is 3, and then we have plus 2. So 15 over 4, and then this equates to be minus 1. So minus 1 is really minus 4/4. So 15 over 4 minus 4 over 4 is 11 over 4. Next, we're going to use that same idea to write the equation of tangent lines. I'm going to work number 4, actually we'll do number 16 together. Because of this minus sign, students tend to mess that up. So this is one that we have to FOIL out so that we can simplify to take the derivative. So I'm going to keep the parentheses because of that minus. So x squared minus 2x plus 1 is still just the second term. I have to distribute the negative to the second term. So 2 minus x squared plus 2x minus 1 simplifies to be negative x squared plus 2x plus 1. The derivative with respect to x as negative 2x plus 2 plus 0. Another way some students do better to think about these last terms if you're having trouble with the x power of 0 is if they did the negative 2x to the first power, and think about this end part is really just a line. If you think about y equals 2x plus 1, we know that the slope of that line is just 2. So that's why we just have a 2 here for the last two terms. Now we want the derivative specifically at the value of x that they asked, which in this case is negative 2. So f prime negative 2 is negative 2 times negative 2 plus 2, or 4 plus 2, which is 6. Now remember, we always use point-slope form. So y plus 7, because it's minus a negative 7, equals m. X minus x1 makes a plus 2. And we stop in point-slope form always on a free response. Okay, for the next part, we're going to find all points on the graph where the tangent line is horizontal. So this is where your Hoy box is going to be extremely important. Horizontal is where you have a zero slope. So that means the derivative, and this is just another notation, if we said y prime or f prime. So our derivative, using the power rule, is 3x squared minus 2x. If we want to know the points, notice it says points, it doesn't just say find an x value. Points are always coordinate points. Horizontal would be where our slope is 0. So if I factor out an x, I have 3x minus 2. So either x equals 0, or if 3x minus 2 equals 0, that means that x would have to equal 2/3. We're not quite done because we need points on the curve. So we need f of 0, which is 0 according to our equation, and f of 2/3, a little bit trickier. 2/3 cubed is 2 cubed over 3 cubed, minus 2/3 squared is 2 squared over 3 squared. Finding a common denominator, I'm going to multiply by 1, which is 3 over 3. So I'm multiplying by 3 on top and 3 on bottom. So we'll just multiply by 1. And I get negative 4 over 27. So the points still aren't written. One of the points is 0, 0. And the other point is 2/3, negative 4 over 27. Okay, same kind of idea for number 18. Find all points on the graph where the tangent line has a slope of 1. That means that we want our dy dx to equal 1. So we're going to find our derivative, which is our tangent slope. When I multiply 3 times 1/3, I really just get 1 x squared. Power rule for x squared is 2x. And the slope of negative 3x plus 1 is just negative 3. I don't set this equal to 0 this time because I want my dy dx to equal 1. So I'm going to set the equation for the derivative equal to 1. So now if I subtract 1 from each side, now this is a non-factorable quadratic equation, but I still have to be able to solve this out. So I would want to set this so that I have x equal to negative b plus and minus the square root b squared minus 4 times a times c is 4 times 1 times negative 4, it's positive 16, all over 2a. So I have to know the quadratic formula. Remember, on the AP exam, there are absolutely no formulas given to you that don't have to do with volume of solids. So you're not going to get any formulas to do any algebra whatsoever or derivative rules on your AP exam. So we have negative 2 plus or minus. We can simplify this out. Negative 2 plus or minus 2 root 5 all over 2. Remember what I said about never cancel unless you factor. You really need to be in the habit of factoring before you cancel. So my x values are negative 1 plus and minus the square root of 5. If we want points, then we would have to actually write them out as negative 1 plus root 5 and find the value of the function. So for expediency here, I'm not going to list it out. You would typically get to be able to do that part on the calculator, or it would only ask you for the x value. But you do need to understand when it's asking for points versus x values. Okay, remember the height, h, in feet of a ball up the ground at t seconds is given by this equation. The instantaneous velocity at one time, remember if you think about velocity, you're talking about things like miles per hour or meters per second. So you're really doing a slope of position over time. When you're doing this at exactly 1 point, it means that you need the derivative. So the velocity at any time t is really the slope of position. We're going to use our power rule. We get negative 32t plus 40. So the velocity at time 2 is the slope of position at time 2. If we multiply negative 32 by 2, we get negative 64. And then plus 40 is negative 24. And if they give us units, we absolutely have to put them. We are measuring feet and seconds. So remember that velocity is a change in position over a change in time. Your input, your x value, is always on the bottom of your slope. So our output was the feet, and our input was seconds. All this means, you definitely need to know the meanings, is that t equals 2 seconds. The ball is falling. That's why it's a negative velocity. At a rate of 24 feet per second. Notice that I did not say negative 24. Falling and the 24 feet per second represents the negative 24 feet per second. Okay, the second half of this question asks us, when is the velocity equal to 0? It does not ask us what is the velocity at time 0. Time is not equal to 0. We want velocity equal to 0. We already have our velocity equation. So we're going to set the velocity equal to 0. We already have the negative 32t plus 40. So if we add 32t to each side, and then divide by 32, both of these are divisible by 4, or they are both divisible by 8. It is still, in this case, a time. It still has units, so the time equals 5 over 4. So our answer is 5 over 4 seconds. You can only turn something into a decimal if it's a finite decimal. No rounding is allowed on a non-calculator question. So this would be 1.25 seconds if you wanted to write it that way. The preferred answer is the 5/4 second. Finally, there are two tangent lines to the curve that go through 0.25. Find the equation of both of them. Notice that this does not say that 2,5 is on the curve. It says that there are two tangent lines that pass through that particular point. You need to know how to graph your parent function. So if I would factor out an x, I would get x times 4 minus x. That means we have zeros at x equals 0 and x equals 4. This is an upside down parabola, and I know this because we have a negative x squared. And I can plot points. If x were 2, I would get 8 minus 4, which is 4. If x were 1, I would get 4 minus 1, which is 3. Similarly, if I have x is 3, I get 12 minus 9, which is also 3. And I can plot a sketch of my upside down parabola. Notice the point 25 is not on that curve at all. The point 25 is up here. What it says is that there are two different tangent lines to this curve that pass through that point. And we're going to find each of those. Now, what's important about tangent lines is the tangent line has a slope that matches the derivative. Every line in the whole world has a slope that we could find with the 2 points. So we're going to let the point on the curve be an xy point. Our derivative is 4 minus 2x. There are two things that are true about this curve in order for it to be tangent. A tangent line touches and it has to have the same slope, so the y primes have to match at xy. Since we know one of the points is 2, 5, and the other point is xy, we have the slope, using Algebra 1, is y minus 5 over x minus 2. We also know that y has to equal 4x minus x squared. So that means that our slope is 4x minus x squared minus 5 over x minus 2. In order for this to be tangent, the tangent slope and the Algebra 1 slope have to match. That means that we can set them equal. So 4 minus 2x has to equal 4x minus x squared minus 5 over x minus 2. Now cross multiplying, we're going to get 4 minus 2x times x minus 2 equals 4x minus x squared minus 5. Foiling, we get 4x minus 8 minus 2x squared plus 4x equals 4x minus x squared minus 5. So the 4x on the left and the right cancel. If I add x squared and add 5, or move the other way, adding 2x squared and moving all my terms over, if I add 2x squared to both sides, I end up with a positive x squared on the right-hand side. If I add 8 to both sides, I end up with a positive 3 on the right-hand side. If I subtract 4x from both sides, I end up with a minus 4x. And I'm left with 0 on the left-hand side. So if I factor, I end up with x equals 1 and x equals 3. That would make sense based on the diagram, that 1 and 3 would be the points of tangency. Remember, a sketch is never a reason, though. Using the original function, if x is 1, y is 4 minus 1, so it's 3. If x is 3, y is 12 minus 9, so also 3. Our slope, if the point is 1, 1, uses the derivative. 4 minus 2 is 2. Our slope, if the point is 3, 3, also uses the derivative. 4 minus 6 is negative 2. And that makes sense based on our diagram that we have a positive slope of 2 and a negative slope of 2. The equations of the tangent line must be written in point-slope form. So y minus 3 equals 2x minus 1. And y minus 3 equals negative 2 x minus 3. Those are the two equations of the lines tangent to the curve that happen to pass through 2, 5. Okay, now we're also going to try this out for powers that happen to be negative or fractional. Now what we have to be very cautious of is that if we have no graph at x equals 0, then we definitely cannot have a function at x equals 0. And we certainly can't draw a tangent line where we don't actually have a function in the first place. Now, we also have to consider things like the square root of x, where they're defined only on one side of the graph, versus something like the cube root of x, which happens to be defined on both sides of the graph. So if we're looking for the derivative, we saw earlier that this derivative comes out to be 1/2 x to the negative 1/2, or 1 over 2 root x. So notice where the function is defined at 0, the derivative is not defined at 0. We don't have two sides there, and if we were to zoom into this very closely, we would see that we have an extremely steep part of the curve there, if we zoom in, where we have an undefined slope because we have an almost vertical slope there. Okay, so we're going to go through just a few of these together as well. I would rewrite 1 over x cubed as x to the negative 3. I would do that so that when I take my derivative, I bring the power down and I subtract. And this is really important. Subtracting does not mean getting closer to 0. Subtracting means going further left on the number line. So further left on the number line is negative 4. So negative 3 over x to the 4th. Notice the 3 is not raised to a power. You cannot put the 3 on the bottom. Similarly, if I had x cube root, I would write the cube root as the 1/3 power. And my derivative is 1/3 x. Subtracting 1, I get negative 2/3. The 1 is on top, the 3 is in the denominator, and the x to a negative power moves to the denominator. And we need to remember our algebra. That's the cube root x to the 2nd power. So you can think about it in terms of trees. Trees have roots on the bottom, and power lines go above them. So power is on top, root is on the bottom. For number 6, I would need to simplify this out. The x doesn't cancel because it doesn't factor out of every term. He belongs with everyone. So if I were rewriting this, x to the 5th over x would be x to the 4th. X cubed over x is x squared. X squared divided by x is x. X divided by x is just 1. That last term is still 1 over x. I can rewrite this still, and notice I have not yet taken a derivative. I don't want you to confuse simplification with having taken a derivative. All I've done so far is I've rewritten the y. That means that my y prime now can be done with the power rule. 12x cubed minus 8x minus 2, technically minus 0, and this last term, I bring the power down and it makes a positive 1, x, and when I subtract 1, I don't get 0, I get negative 2. So this is 12x cubed minus 8x minus 2 plus 1. X to the negative 2 means the x squared goes on bottom. Okay, similar to before, finding derivatives. I'm going to rewrite this. 3x to the 1/5 minus 2x to the 1/2 plus 4, so that my derivative at every x in the domain is 3 over 5, because 3 times 1/5. X subtracting 1 makes negative 4/5 minus, now 2 times 1/2 is just 1. X subtracting 1, I get negative 1/2, and then plus 0. Never ever substitute your numbers in to negative powers. We're going to rewrite this as the 5th root of x to the 4th minus, and that's on the bottom, should have written that a little clearer, because it was a negative power, so it's on the denominator, 1 over the square root of x to the 1st power. Now that means that f prime of 32 is 3 over 5, 1 over the 5th root of 32. Do the roots first. The 5th root of 32 is 2. And I still have to raise it to the 4th power. And then the square root of 32, 32 is 16 times 2. So 2 to the 4th is 16. 16 times 5 is 80. So I have 3 over 80 for the first fraction. The square root of 16 is 4, and then we have radical 2. The nice thing about College Board is that they don't make you simplify those radicals at all. Okay, so we'll do the last two together as well. Now, notice this one, we're not putting 4 in. We're setting the derivative equal to 4. So first I'm going to rewrite my equation. 13 minus 8x plus, notice that this square root is not over the x squared. It's just a constant times x squared. So I want to make sure we notice that we're not raising the x itself to a half power. So the derivative of 13 is 0. The derivative of negative 8x is negative 8. Or again, you can think about that as a linear, and the slope is negative 8. For this part, we're going to bring the power down to multiply, so we get 2 root 2, and then x is just to the 1st power. We tend not to write the first power because it's understood, but also because it looks like a prime, and we don't want to confuse that with a derivative. Notice we're not substituting 4n, we're substituting cn. So negative 8 plus 2 root 2 times c, and we're setting that equal to 4. So if I add 8 to both sides, I get 2 root 2 times c equals 12. If I divide by 2 root 2, 2 goes into 12 6 times, and that is an acceptable answer. You could rationalize that if you wanted to multiply by your fancy 1. So my fancy 1 is root 2 over root 2. I would get 6 root 2 over 2, or 3 roots of 2. Both of those are acceptable answers. The last one in this lesson. Find the equation of the tangent line to the curve at the point 1, 2. We want the equation of a line. The equation of a line is always point-slope form. So our derivative is 3x squared plus 1. The derivative, watch the notation, you need to know this notation, at x equals 1 is equal to 3 times 1 plus 1, or 4. So I now have the point and I have the slope of the tangent. So the equation y minus 2 equals 4x minus 1. Okay, that's the end of today's recording. You'll need to finish the rest of this packet and check your answers online.